Acids and bases. So simply put, acid is a compound that releases hydrogen ions when dissolved in water. Hydrogen ions may be described as protons. So if you remember the atomic structure, a hydrogen 1 atom consists of 1 proton and 1 electron. So when it is in the hydrogen ion form, it is only left with 1 proton. So if you ever see that word, you may relate it to it being a H+. So here are some examples of acids because they all produce hydrogen ions in water. This is the equation for this dissociation. Sometimes some acids dissociate partially, not completely, and these are known as weak acids. Those that dissociate completely will be known as strong acids. In the general rule of thumb, whenever you see this COOH, you can guess that it's going to be a weak acid. We'll cover more of this in the organic chemistry chapter. They have these following properties, very common ones: sour, they dissolve in water to conduct electricity. Because of the ions, they can carry charges from one point to another. Turns litmus paper red. So if it turns litmus paper red, of course it's going to be the blue one to the red one, not the red one to the red one. And anything that's got to do with acid, you can think of it as things that are of the red color, the red, orange, yellow range of colors in the rainbow. They also react with metals to form salt and hydrogen gas. Here are some examples. This is an example. Some metals are so unreactive that they will not produce any reaction when in contact with acids. Things like copper, silver, gold, platinum, because they are very unreactive. And this will be covered in the reactivity series in perhaps the metals chapter in later videos. However, some reactive metals, like for example lead, react so quickly that they form an unreactive layer that is insoluble and forms a protective coating around the remaining metal, stopping the remaining reactions. Acids also produce carbon dioxide and water when reacted with carbonates. Here's an example. Also reacting with bases, metal, which is the metal oxides and hydroxides, to form salt and water. Here are some examples. Hydroxide is also a base, that is the soluble version. So metal oxide is an insoluble base, hydroxide is a soluble base. So we'll talk more about it later in this chapter. When dissolved in water, the water is a polar compound, so it is slightly charged, not fully charged, like removal of one electron or gaining of one electron. Its job is to pull the H+ away from the anion, thereby helping the dissociation to occur. And through that, the dissociated H+ ion will give the acids their acidic properties. Okay, that's pretty short. Next, we are talking about bases and alkalis. A base is a class of chemicals that a metal oxide or hydroxide that reacts with an acid to produce salt and water only. So here are some examples. An alkali, namely a metal hydroxide, like mentioned earlier, is the soluble class of bases. It is able to dissolve in water to form the hydroxide ion, OH-. So for example, when a metal oxide dissolves in water, it produces a metal hydroxide. Interestingly, also, the ammonia gas dissolves in water to form the hydroxide ion. Therefore, it is an alkali. Alkali is a substance that produces OH- ions, hydroxide ions, in aqueous solution. So opposite of acid, the properties of alkalis will be bitter taste, soapy, turn litmus paper blue, reacts with acids to form salt and water only, and this reaction is commonly known as the neutralization reaction. The H+ ion will react with the OH- hydroxide ions to form water. Alkalis also release ammonia gas when heated with ammonium salts. The pH scale. The pH is the measure of the concentration of hydrogen ions. It actually has a formula like that, but you don't have to know. And why is this pH scale important? Because the concentration of hydrogen ions or hydroxide ions are literally reactive particles that can cause a certain reaction to occur. Too much of it can harm something. It may be the environment or even your health. So it is important to understand what is going on. And usually in the pH scale, it is commonly and conveniently measured today using the data logger. There's a probe that you need to calibrate it, and then you put it into the sample to get your reading. At school level, you may be exposed to things like universal indicator that produces all kinds of colors in different pH solutions that you will need to know the color sequence of where the pH is in the pH scale. It follows the rainbow colors, ROY, G, B, I, V. After teaching for several years, sometimes your students are the one that shares tricks with you. So I learned this from my student. Roy gives birth in Vietnam. There's a simple mnemonic over there. So the closer it is to the first color, the more acidic it will be. The closer to the last color, the more alkaline it will be. And if it is in the middle, the green one, it is neutral. And a whole lot of other indicators are stated here, and what color it changes from to what color it changes to, and the pH range where it changes color is not necessary for you to remember them, commit them to memory. If it is required out of you, you will be informed. And one of the important points that you need to know is the controlling of acidity in the soil, namely to raise the pH or reduce the acidity. And all kinds of calcium compounds can be introduced into the soil to help raise the pH for the crops to grow, for the animals to thrive over there. So quicklime, calcium oxide, slaked lime or lime water will be calcium hydroxide, and the other limes. So once and for all is all stated here. I always get confused by them myself. And moving on to the last part of this chapter, we have to be talking about oxides. There are 4 kinds of oxides: acidic, basic, amphoteric, and neutral. So acidic oxides are oxides of non-metals dissolving in water to form acid. So these are some examples and the acids that they produce. Acidic oxides also react with alkalis to form salt and water. So you can see over here, silicon dioxide is also an acidic oxide. Basic oxides, like mentioned earlier, are oxides of metals. Most of them insoluble, but some dissolve to form alkalis. They react with acids to form salt and water. Third on the list is amphoteric oxides. So they are also metallic oxides, but they are able to react with both acids and bases to form salt and water. So zinc oxide is an amphoteric oxide, aluminium oxide, lead oxide that forms the mnemonic ZEP. Finally, neutral oxides are oxides of non-metals. They don't show any basic or acidic properties, insoluble unless it's water itself. And here are some examples of neutral oxides. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe and share it with somebody who needs to see this. And I will catch you in the next video. Bye!